How do you find an inverse function of a function? There are some steps to take. First is to actually find out if the inverse function exists by the horizontal line test. Secondly, you would replace the f of x with a y and then interchange the x and the y. That makes sense because when you go from function to its inverse, you're switching the x and the y, or the domains and the ranges. Then you're going to solve for the new y and replace it with f inverse of x. And lastly, state any restrictions on the domain. So we'll do that in just a little bit. A couple more characteristics of inverse functions. One is that when you take the composite of inverse functions, you're always left with your x. So it's kind of like you're doing something to your x and then you're going to undo it and get back to that same x. The other characteristic is that you have actually a reflection line over the x equals y line, which makes sense because if you had an xy here, the point that gets reflected is going to end up being some sort of yx point, and that's going to reflect over the line that is equal to y equals x. Let's do a few examples. First of all, we're looking at determining if the f of x has an inverse function. If it does, state what the inverse function is. On the first case, it passes the horizontal line test, so it does have an inverse function. The second one is a parabola, and the parabola would be located over here somewhere, and you would see that if that's the case, it would fail the horizontal line test. It intersects in two places, so this does not have an inverse function. This passes the horizontal line test. It would have an inverse function. This passes the horizontal line test. It does have an inverse function. Let's go ahead and figure out the inverse function of the first one. And so again, you replace the y into the f of x, and then you switch the x and the y around, just like you're changing your point xy to yx. And you're going to solve for that new y. I'm going to add 4 and divide by 2. And therefore, your f inverse of x is now equal to x plus 4 over 2. And there are no restrictions on that domain. Let's take a look at number 3. Same idea. So let's see, y equals. Notice how I'm working down here. I always try to keep my equal signs lined up. At this point, you want to solve for that y. So what I would do is actually do the inverse, raise each side to the -1 power. And when you do so, you end up getting this. And so now to solve for that, you're going to have multiply by 5 on both sides, 5 over x, and add 2 to get your y. In other words, f inverse of x here is equal to 5 over x plus 2. And x cannot equal 0 in that particular inverse function. So to find the inverses, you replace the x and the y, you solve for the new y, replace it with f inverse x, and then you're going to state any restrictions on the domain.